Okay, so now I'm going to give you two numerical examples how to actually construct a confidence interval. The first one is how do you construct a confidence interval for a population mean given I think 36 examples. The second one is a difference of two means, before and after improved process and so on. So here, over here, you see this is a formula. And don't worry about memorizing this. This is in every standard statistical probability book. But mainly I want you to understand, as we talked before, X bar is the sample mean. The S is the sample standard deviation. N is the number of sample points. This T is the T value that leaves 2.5% area to the right. Why 2.5? We're doing 95% confidence level. 95%. Therefore, 1 minus 0.95 is 0.05% divided by 2 is 2.5%. Why? Because we're doing two-tailed. Why? Don't ask. Anyway, so we need to find the T value, as you see on this table. Sorry, this is Z value, but I refer to you where T is later on. You can cheat with a standard normal table Z value when your sample size is larger than 30. So remember this. Happiness is finding sample point larger than 30 in doing statistical analysis. So the first example says, I wanted to make sure my aspirin that I'm producing, the population mean, it should be 325 milligram per tablet. And they restrict this very stringently, too much, too little, it's not good enough. So I went out and did a sampling, random sampling of the tablet I produced, and I had 36 tablets. I found the average of the 36, which is X bar, the average of 36 sample, the contents give me 325.09 milligram per tablet. And I also calculated the standard deviation, which is very standard. I'm not going to talk about how to do that, but if you calculate the standard deviation of these 36 tablets, you find 0.5 milligram. So now, based on this, I want to know what is the true population mean, the content of all the tablets I produce, could be millions or 5 million per year. I want to make sure they are within some narrow range, according to some FDA, for instance. So, as you can see, that is a formula. So it's going to be X bar minus something, and X bar plus something. And this interval is called the confidence interval. Let's just go from that. So this delta then is T, when you have n larger than 30, use Z table. What is Z table? The standard normal distribution table, which I show over here. And we wanted to know the the Z value that leaves 2.5%, which is right here. 0.025% area to the right. And what is the Z value? You look over here, it's 1.9, and the second digit is 6. So it's 1.96. So we use a Z value here because we have a larger than 30. So Z of 2.5% is 1.96. Then S is this value right here, 0.5, and it says, so we're in business. So Z of 2.5% times S squared N is equal to 1.96 times 0.5 divided by square root of 36. And if you calculate this, it turns out to be 0.163 milligram. And that's its delta right here, which is this portion. Therefore, X bar, which is our 325.09 minus 0.163, smaller than mu, is somewhere in that interval. We don't know where, but we know with 95% confidence is somewhere in this interval. So let's go ahead and do our arithmetic, clean that up. And this, I hope I didn't do it wrongly. I did this last night around 10 o'clock. As you know, I'm no longer a spring chick, young person. So I hope I didn't mess up this arithmetic. Anyway, if I did, just bear with it. 253 milligram. So you see how, so what's the interpretation? Well, I'm going to switch to a different one. So you say, hey, you want to know population mean, the content I don't know that without sampling all the tablet, but I can tell you with 95% confidence, it's somewhere between 324.93 milligram and 325. Say, is that's a difference of 0.32. Is that too big? Is that to be FDA approved, for instance, the claim purity? Well, if it's too big, what do? You up to 36. Oh, I'm going to stand over here. So if you 4 times this, 4, that's 144. Then you reduce this interval delta by half. So this becomes 0.08. And then the whole thing shrinks down a bit. That's how you control the sample size, the confidence interval. So this is our confidence interval, ladies and gentlemen. This is so-called confidence interval for the population mean. You see, based on X bar, S, and so on. Okay, so now